con los terroristas.
You are now about to witness the strength of street.
When something happens in South Central Los Angeles, nothing happens. It's just another brother dead. Straight out of Compton, crazy killer named Stoller. Look at me and I'm colder than a polar bear. So take a step back, got a gun pointing at your rear. That's how I do it. This is the end of the music.
While Harlem Shaking by Lake Compton, Sean was shot by Stoller, the man straight out of Compton. Sean's body, 98.6 degrees Fahrenheit, falls into the lake, 40 degrees Fahrenheit. An undetermined time later, inspectors find his body at 45 degrees Fahrenheit. While searching the scene, an inspector drops his coffee jug, 120 degrees Fahrenheit, into the pool. By the time he fished it out, 5 minutes had passed, and his coffee was 95 degrees Fahrenheit. Assuming both Sean and the coffee jug lose heat at the same rate, find how long Sean has been dead for.
Breaking news. Sean Lavender's body was found deceased at Lake Compton late this night. A man straight out of Compton presumably killed him for Harlem Shaking, an activity not violent enough for the streets of Compton. Okay, to find the rate at which the person loses heat, we first have to find the rate at which the jug loses heat, because that's what's given in the problem. So to set up the equation, you first write the final temperature at which the jug reaches, which would be 95, is equal to the ambient temperature, which is 40, plus the starting temperature of the jug minus the ambient temperature, which would be 80, times e to the RT for time. In this problem we're doing it in terms of minutes, so that would be 5R. So then you subtract 40, you get 55 is equal to 80 e to the 5R. You divide by 80 on both sides, and then you would get 11 over 16, once you simplify it, equals e to the 5r. Then you take the natural log of both sides. Remember, it's an operation, not something you multiply by. So then you get the natural log of 11 over 16 is equal to 5r. Then you divide by 5 on both sides, and then you get that your rate is the natural log of 11 over 16 divided by 5 is equal to r. To keep things simple, we're just going to put a box around the r so we don't have to deal with decimals and error. So then we use this rate to calculate the time it took for the person to cool down. So to set up the equation, we're going to write the final temperature the person reached, which was 45 degrees, is equal to the ambient temperature, which is 40, plus the starting temperature minus the ambient temperature. Starting temperature would be 98.6, minus 40 would be 58.6, times e to the rate times time. In this case, the rate will be what we have here, so we're just going to put it there in a box, times the time, which we're finding. Subtract 40, you get 5 equals 58.6 e to the box RT. Divide by 58.6 on both sides, you get 5 over 58.6 equals e to the box RT. Then you take the natural log of both sides. Natural log of 5 over 58.6 is equal to box R T Then you divide by box R on both sides to get your time. Then you take these numbers and plug them into a calculator. You have the natural log of 5 divided by 58.6, all divided by R, which would be the natural log of 11 divided by 16 divided by 5. And make sure you use the right number of parentheses. In the end, you get 32.844139949. So that means it would have taken 32 minutes for this person to lose their heat. But then we're gonna find the number of seconds too. So you take this whole number, you subtract 32 to get just the decimal. Then you multiply the decimal by 60, because that's how many seconds are in a minute, to get 50.6. Round that off, you get 51, which means it took 32 minutes and 51 seconds for this person to lose their temperature.